Hello, in this video we're covering the work energy theorem for a rigid body. Before we cover the work energy theorem as a whole for the rigid body, we first have to introduce or define or calculate even the kinetic energy of a rigid body. This is the expression we get for the kinetic energy of a rigid body. This form is called the conic decomposition. You can see that the kinetic energy of a rigid body is due to translational motion, this term, and rotational motion, this term. Now in the special case where omega is just along EZ, then the rotational term simplifies to this. Now, in the case where the body is rotating about a fixed point, this expression for the kinetic energy simplifies to that one. Where again, if the rotation is just along EZ, the kinetic energy's expression simplifies. And then we can write the work energy theorem as such. So the work energy theorem has two forms. That's the derivative form of it. We can write the derivative of the kinetic energy as F. F is the sum of the total forces acting on the system times the velocity of the center of mass. So if I had here, I could imagine this as two equivalent systems where F is the sum of forces now acting at the center of mass, and MC is the moment of all the forces acting at the center of mass, MC. These two systems are equivalent, so we can write the work energy theorem in terms of either the first system, this one, or the second system. Okay, and so integrating now this expression, we get that the change in kinetic energy is equal to, in the case of the blue, the work of each force plus the work of the couple, and in the case of the first form, the yellow form, that's the work of the sum of the forces plus the work of the sum of the moments or the resultant moment about point C. So then how do we calculate the work of a force? As we did before, that's the integral of the force times the velocity dt. But now we're not working on it. We're not working with the particles anymore. We're working with rigid bodies, and different points on rigid bodies have different velocities. So then the work of the force is the integral of the force started with the velocity of the point of application of the force. So here the force is applied at the center of mass, so the force started with the velocity of the center of mass. And here the force Fi, each force Fi is applied at a point with velocity Vi, so to calculate the work of that force, we start with the velocity Vi. The work of the moments is just the integral of the moment dotted with the angular velocity omega integrated with respect to time. Okay, so that's just explaining kind of the equations. In the next few videos, we'll derive them. We'll start by deriving the expression for the kinetic energy.